what do you do? If you're gone, you want to ask questions, what do you do? Reply to the remind, right? And let's go there. Class is live. Here's the link. Love, haha. All right, here we go. Today, 68, 95, 99.7 rule, 68, 95, 99.7 rule. Darn it. Hey, 68, 95, 99.7 rule. Goal for today's learning. What are you going to get out of today? Number one, given a data set, find within two standard deviations. Don't forget standard deviation when we have the entire population. That's going to be that sideways 6. And number two, find what scores would be for 95% of the data. What I was trying to get that JavaScript to show, and it does such a good job of, is if you had your little Plinko board here, and your 10,000 is in the middle, and those of you that watch The Price is Right because you're home all summer and that's what you watch at 9 a.m. every day, what's right next to the 10,000s? The zeros, right. So even though you're aiming for the middle, if you're off by a little bit, you get nothing, and then there's smaller and smaller and smaller and smaller amounts as you go to the side. I think the last one's $100, but sadly, I don't have a lot of 9 a.m. time off anymore, so I don't remember what it is. But what do you think would happen as you put the Plinko chip in like hundreds and hundreds and hundreds and hundreds and hundreds and hundreds of times? Yeah, what do you think that if you started making a dot plot though, like here you got that, that, what do you think it would look like as you put in like hundreds and thousands and millions and you dedicated your entire life to just putting Plinko chips down? What do you think the data would look like as the number of times you ran the Plinko chips got larger? What do you think the data would look like? If I gave you a big clue by writing it up there first. Box, Ethan?
Like that wave thing.
That wave thing? Anybody know what that wave thing is called? Yeah, this thing is called a bell curve. But you should never, ever call that again because now you're really smart. You should call this a normal curve. What did I have to type into Google to get this? I had to type in something called the central limit theorem. And what the central limit theorem says that as you run any numeric data, as the number of times you run that data gets larger and larger, the data will look approximately like a normal curve. And that's why it's called the normal curve. It's because what we normally anticipate to get from a large data set. Same with test scores. They naturally collect around the mean because most people will score around each other if they've had the same experiences. There will be outliers away from that, but as we get larger and larger and larger data sets, we can start to assume that the curve will look more and more and more and more normal. So what is that? Something from a 400 level math class, but I will show that to you because I'll get it to work next time, or I'll just bring my own computer. The central limit theorem. What does the central limit theorem say? Central limit theorem says that as the number of data points you get gets very large, the distribution of the data will look approximately normal. A bell curve is what it's called because it looks like a bell, but it's what you should normally expect. It's a normal distribution. Giving a normal All right, we'd like to make the class real life. Think of something that a lot of people your age would do, that we would get data from a large number of them. Snapchat, the number of times you snap per day. Oh, God, help us.
Number of times you look at your phone.
Number of times you look at your phone. Is there really somebody collecting data on that? Like, are your parents standing over you at night and going, no, I'm just going to see how many times you look at your phone today. Don't change your behavior. Act normal.
The Apple might.
Apple would? Yeah, they probably know the number of times you look at your phone. Why would they want to know that?
It's just something that they could access.
Stalking you? Michael, what'd you say?
It's just something that they could access.
Okay. What do we do for warm-ups every day? What do you do for warm-ups every day? You practice safety. Do a lot of kids take that?
Yes.
Yeah, there's a few. There's hundreds of thousands that take it every time it's given. The classic normal curve example for high school students is ACT score distribution. Kind of weird, but the average score is the same every single time people take the ACT. Oh, that's inadvertent. When we make, I'll talk about colors when we need to. The average score is always the same. It's the same every single time. Why? Because they adjust the mean to always be 24. So 50% of people that take the test score higher than 24. 50% of people that take the test will score lower than 24 every single time. X with the bar over the top, that's the quick way of writing mean, in case you weren't here when we talked about that day. The standard deviation is always 3. How do you get a 36? You'll see. It's not actually what you get for a score. It's the percent of people you beat. They could just as easily just give you your percentile. But kids don't like hearing 13 percentile. They don't mind if they say, oh, you got a 10 on the ACT. But hearing 13 percentile, like, oh, wait a minute, I only beat 13% of people, that hurts feelings. So all they did a long time ago was just change it from percentiles to what's called a norm reference score. In other words, they use the same mean, the same standard deviation every time, and how many people you beat determines what your score is. So if you were in the 36th, if you get a 36 on it, you're in the 100th percentile. You got the same or higher score than every single person that took the test. If you get a 0 for your score, that means you got the same score or lower than every single person that took the test. It's all norm reference. It's based off of norms. So what does that mean for you? Are there a large number of people that take it? Absolutely there are. What does it mean is we can predict your percentile because N is very large. And there are two things we're going to learn about it. Today we're learning the 68, 95, 99.7 rule, which is all about the word between. What percent of people will score between these two numbers? 95% of people will be between what two numbers? 68, 95, 99.7 rule. What we're going to learn on Friday is called Z-scores. Z-scores are all about better than. That's where you truly get percentiles. Today is all about between. What percent of people will score between? Because I've told you before, in business, we largely care about where's the middle part, because that's where we can hold the least number of size and sell to the most number of people. If you know the mean size of your customer, the standard deviation of your customer, we could find, like, where can we stock the least number of sizes and get the largest number of customers? Or for donuts, like if people walk into a donut store and most of them want to buy 6, we will want to sell something that sells to about 6 people, or to 6 donuts. If the smallest container you have is 35 donuts, you're probably wondering why people walk in the store and then walk out when they realize that you can't meet their needs. Today is all about in between, because in business, that's where it's profitable, because that's where you can sell the largest number with the least amount in stock. Z-scores is what we're talking about Friday. That's where it's better than. Okay, so notice how I'm at the end of a sheet of paper. You should be at the end of the sheet of paper, because you'll probably want an entire sheet of paper for this, and you're going to turn your paper sideways. And here's where you're going to need 3 different colors. You will want to leave about 1/3 of your paper down here at the bottom. So notice I'm showing you where my bottom of my paper is. You'll want to leave about 1/3 because we're going to write a lot of stuff down here. So I'm going to draw a line with about 1/3 of my paper below. I'm going to move this up as high as I can, and I'm going to draw myself a normal curve or a normal distribution. I'll show you. So you will need some room to write down beneath. That's the big mistake you can make, because you don't have your room down there, because we're going to write some stuff down there. Today is all about between, though. It's not about better than. Okay, so notice I have my first color. I'm using green for my first. Of course, it doesn't really matter what color you use. In the middle of this here curve would be the what? The mean, right, because 50% of people are bigger and 50% of people are lower. You may say, wait a minute, the median in a large data set, the mean and the median will be extremely close to each other. In a large data set, the mean and the median will be extremely close to each other. So in the middle, I'm going to put an X bar and I'm going to draw this puppy in half. I'm still on green, yep. And it doesn't matter what color you use. But this is the first color I'm using. Okay, so let's imagine real quick. Above and below. So our mean for the ACT is going to be equal to what score? 24, right. The standard deviation is equal to what? 3. So let's label a spot off here that is the mean minus 1 standard deviation. And let's go the same distance on the other side, the mean plus 1 standard deviation. I'm still in green. I'll let you know when I switch colors. Ain't that colorblind. Okay, so here's what I'm going to draw out. That should be straight. I'm sorry, that should be straight there. Okay, a question. What's our standard deviation again? 3, right. So if I have the mean and I subtract 1 standard deviation, what ACT score would that be? 21. Good job. Questions on how I got 21? So that's going to be the number 1 question you got tonight is, how did I get that number? Okay, let's go above real quick. Don't say it out loud, just to yourself. If I take the mean and add 1 standard deviation, what ACT score is that going to be? Just say it to yourself. Don't say it out loud. Give people a shot to think. Okay, just say it out loud. What score is that going to be? 27. Okay. Question. What percent of the data do you think is in between that? What percent of the data do you think is in between that? Talk the first thing next to you. 50% would be, and I want to show that, 50% would be right here. There's 50% of the data right here, and there's 50% of the data right here. Talk the first thing next to you. What percent do you think that is between those two numbers? 1 standard deviation below the mean and 1 standard deviation above the mean. Yeah, but you're not going to explain why she doesn't have that. How could the deviation be lower than the average? If your mean was 400 and your standard deviation was 600, you'd have to have some cell bills that were in the negative, like the cell phone company paid you.
She'd rather have a larger one.
Did you just tell your mom to say, Mom, reply to
No,
this
I
email?
watched it.
Oh, yeah, sure. $5 for every
No.
volunteer, what percent of the data do you think is in between those? 50%? 50? Okay. Nobody's going to be clever and look at the title of the lesson. Yeah, what?
95.
Not 95.
68.
68%. 68%. If you take your mean of a large data set, you take your mean of a large data set, and you go 1 standard deviation below and 1 standard deviation above, approximately 68% of your data will be within 1 standard deviation of the mean. So I'm going to say that. I'm actually going to write it for this one. 68%, and it is approximately, if you have a PhD in math at home, I know it's 68.34971. It's high school, 68 is fine. 68% of data is within 1 standard deviation of the mean. It's the only one I'm going to write it out for, but I do want you to go home tonight and understand what I was talking about. Okay, so ACT, yeah, you can relate to that to high schoolers, but let's say you own a donut shop and you interview 5,000 people and say, what is the price that the biggest price you'd be willing to pay for 1 glazed donut? And you find the mean is like 75 cents. Should you charge 75 cents? No, wait a minute, because hold on. Some people are willing to pay more than that. Some people are willing to pay less than that. 68% of people will be willing to pay between these two numbers. Or thinking of sizes. If you found the mean size of the customer you're looking for, and you went 1 standard deviation below, 1 standard deviation above, 68% of people would fall within that. In other words, if they came into your store, you would have it in stock. That's what Costco does. They stock for 68% of their customers. If you notice in Costco, like I'm really tall, they never carried my size. Why? Because I'm more than one standard deviation away from the mean in length. They will never have my size in there. I got to go online in order for them if I want to. But they look for, okay, 68% of people. Because what happens if you stock for 100% of people? Yeah, you've got a lot of sizes that people may or may not ever buy. But if you look in that middle, 68% of people will find the size they want. If they like what it is, they'll be more likely to buy it. So that's finding the balance between carrying too much inventory and offending people because you don't have their size in there. What percent of people are outside of that, though? Are either going to score better on the ACT or worse on the ACT than 21 to 27? 32%. So 32% of people are outside of one standard deviation. 68% of people are within one standard deviation. Okay, a Doug question. What percent of people would be right between those two? 34, right. So 34% of the data is in between these two numbers. What percent would be over here? 34. Okay, I'm done with the first color. What's the 68, 95, 91.7 rule? It's all about in between. What percent of people are in between two numbers? What 68% is between what two numbers? Let's go to the next one. What if we go 2 standard deviations out, which will be about right there and about right there. So the mean minus 2 standard deviations, the mean plus 2 standard deviations. So we go out here, and I'm going to catch through my writing, but 95% of the data is in here. So in other words, 95% of people are within 2 standard deviations of the mean, either above or below. That's almost all your customers in a business. That's 19 out of every 20 people that walk through the door. What's the ACT score that relates to that? If we take 2 standard deviations, what score would we be at? So our mean is 24. What's our standard deviation? 2. Or no, the standard deviation is not 2. It's what? 3. So what's 2 times 3? So 24 minus 6 is 24 plus 6 is 30. 95% of people that walk in on any ACT day will score between 18 and 30. So that's why you have to, just time it where you take it with all the kids that are slackers, and you beat more kids, not because you did better, but just because it was a lower group that you're competing against. Okay, now a little bit harder question. What percent of the data is between these two numbers? What percent of the data is in there? You'll probably have to take out your what?
47.
Okay, what did you do to find that number? 95 divided by, yeah, because half of the data is between these two, half of the data is over here. So what'd you get, Alex?
42.5.
Are you sure about that?
47.
47.5, right, 47.5. So 47.5 is in here, and there's 34% in here. How much is left for over here? 13.5, right. So there's 13.5% of the data right here, and there's 13.5% of the data right here. Okay, look up real quick. What percent of people score between 18 and 27? What percent of people score between 18 and 27? 81.5, right. How did you get that number? Add that plus that plus that. Okay, what percent of people score between 21 and 30? Okay, so this is the higher 81%. This is the lower 81%. And you'll notice with a lot of these, there's a lower 34%. There's a higher 34%. Stop and check up. Questions on that? Today is all about what? In between. What's Friday about? Percentiles. Better than, yeah. So I'm going to say it again just so I drill it in your head. What's today about? In between, right? Okay, last one. New color. Now, 3 standard deviations to the mean. 3 standard deviations to the mean. So that's almost everybody, because 99.7% of data is in there. So there's only 0.3% that's not. So X bar minus 3 standard deviations all the way to X bar plus 3 standard deviations. Okay, you know the question I'm going to ask. What's the score on the low end? What's the score on the high end? Ready, set, math. What's the score on the low end? What's the score on the high end? Bless you. Volunteer, what's the score on the low end? Liberty. 15, right. What's the score on the high end? Somebody else? Volunteer, volunteer, volunteer. McCree, you've already talked today. Somebody else?
33.
Yep. Oh, no, who hasn't talked today? All you people raising your hand have talked today. Yep, Brenna. 33. Do you know people that have scored better than a 33 on the ACT? Yeah, at this school, you probably are going to know a lot of people that score better than 33, especially after you practice and do these techniques that we're talking about in class. You're going to rock that thing. Are the people who score better? Yes. Not very many. In fact, if you look at the percentile, it's way less than 1%. Okay, so then let's do the magic thing again. Okay, 99.7% of your data is in there. Now, here's where you get to, okay, if you're a business owner, you want darn near everybody. So that's 997 out of 1,000 people. If you carried enough for those, 997 people out of 1,000 that walked in your store would be able to find their size there. Why don't stores do that?
Way too much.
Yeah, you just have to carry way too much inventory. And if you're a business owner, you know the killer of profits inventory. The killer of profits inventory. Because if you have stuff sitting on your shelf that's not selling, that's going against the stuff that's walking out the door that you're selling. But if you're looking that you want to be able to sell to everybody, yeah, 99.7 is darn near everybody. 997 people out of 1,000 is a really good ratio of inventory stock. You can imagine 997 people that come in and take an ACT are going to score, 997 out of 1,000 are going to score between 15 and 33. Now, you may notice, wait a minute, there's only how many numbers over here that are bigger than this? 3, but there's how many numbers that are over here? 15. Is that okay? Yes, that tells you your variability is on what side, the high or the low. There's lots of variability on what side, the low side, right? There's lots of variability on the low side. There's not much variability on the high side. And that should make sense to you because the cluster of people that score high are very close to each other. The cluster of people that score low are very low. Because some people walk into ACT and they're like, screw this, I'm not going to write anything down. Like, I'm going to show my mom what's up. Yeah. And some people like go to a school not as good as DCC and they don't have the opportunities you guys have. And they just don't get access to the learning you guys have. Okay, let's do the magic though. 99.7 divided by 2 is what? 49.85. Good job, whoever knew that off the top of your head. 48.95 minus 13.5 minus 34 is 2.35. Good job. 2.35% of the data is between 15 and 18. 2.35% of the data is between 30 and 15. And a Doug question, if 99.7% of people are between those two numbers, what percent of people are outside of those two numbers? 0.15. So 0.15%, not very many, are below 15, and 0.15% of people are above 33. Here's what I suggest for all the homework problems you do tonight. Make this chart immediately. People that make the chart get these right almost 100% of the time. It's actually kind of hard to miss it if you make the chart. If you don't make the chart, yeah, and you kind of wing it, some people get it right, some people get it wrong, but I make it immediately. I would include filling in these numbers and your data points up here. So here's the type of questions you're going to be asked tonight. What percent of people on the ACT scored between an 18 and a 33? On your own. Ready, set, go. What percent of people score between an 18 and a 33? Ready, set, go. What percent of people scored between an 18 and a 33? Volunteer. Somebody hasn't talked today. Somebody else. Forrest. What percent of people?
7.35.
Let's get that number. Yeah, just add it up, all the numbers in between. I'll add it up, all the percentiles in between. Can you do this for a small data set? No, you talk to 5 of your friends, you can't apply this rule for it. The number, don't go home and tell your dad I told you this number, but the number that's approximately for this is 30. If you have 30 people in a data set, you can apply the central limit theorem. Now, applying it at 30, the caveat I want you to tell your dad for tonight, or any of your parents, is you have to have 30 really good data points. The ACT, yeah, whatever you get on your score sheet is what you got. Don't do that for GPA. Don't ask 30 people their GPA in front of the whole group and be like, yes, I'm going to apply the central limit theorem. Why not? There's too much bias, right? There's way too much bias in that. Your data is not good. And remember, you can't make good conclusions off of bad data. ACT, yeah, the ACT knows what you got. There may be a clerical error once in a while, but that's pretty good data. GPA in front of a group of people, not good. Okay, let's do one more question. What percent of people score higher than a 27 on the ACT? What percent of people score higher than a 27 on the ACT? Ready, set, go. What percent of people score higher than a 27? Volunteer, what percent of people, somebody else. You gotta get some more people talking. McCurdy, I appreciate you raising your hand first every single time. I realize that's how you obviously, I hope your phone shut off because you're probably getting text messages from ladies like all over the place. Like, boy, that guy knows his math. Yes. Aliana, you've already talked to. Somebody else. Meg, yes. What percent of people score higher than a 27? How'd you get that? Do you add the 0.15 in?
Yeah.
Thank you, Meg.
Yes.
Why do you add it in?
Because it's after the.
Any questions on that? I've mentioned like retail stores over and over again, because if you own a retail store, at some point you're gonna have to make the decision, like how much inventory am I gonna carry? What percentage of customers do I want to be able to walk out the door with something? Because obviously you can carry every size on your website, even like a website that applies to a lot of people though, like you can imagine the bottom percentile, like how far are you gonna have to go down, and how often are you gonna sell that, and is that gonna be profitable for your business? Like I mentioned, inventory is the killer of profit. If you have stuff that just sits on the shelf, it's not making you any money. In fact, it's costing money because you got to pay for it. Think of another application that this would be useful for. Another application that this would be useful for. Ethan, you see the brain working there. Haven't got one? Claire.
Well, if you go by the baker, you realize nobody wants to eat the raisin cookies. Don't have to make all of them because raisin.
Yeah, you're just making it for your own entertainment. Or you're taking home to your kids all the time. Okay, interstate. Think of something the state would want to know about interstates. Number of accidents, okay. Number of accidents per day.
Yeah.
Because that could be used to do something. Okay, like what? Because it's very bad to walk into a job and say, here's something you want to know. And then they ask, why do you want to know that? And you're like, because you want to employ me. I need money. Think of they want to know number of accidents. Let's even be more specific. Let's say accidents between Colorado Springs and Denver on I-25. What do they want to know that for? Liberty.
Maybe how many cops are on the road.
Yep, staffing. How many cops are we going to need? Because the more wrecks probably means more cops. Right on. Somebody else. What else do they want to know that? Yep, Alex.
Well, all these accidents are occurring in one central place, and all of like safety in that part of the highway.
Okay, and that would be really good. The distance from Colorado Springs of the accident that you're at, because if we notice that like 99.7% of our data is between these two numbers, and those numbers are really close to each other, there's probably an issue there. Like probably Monument Hill would be a place there's lots of accidents, but besides leveling Monument Hill, I don't know what we could do, but I guess we could do that if there were enough accidents. Yes, take kids that don't want to go to high school anymore and have them dig. They'll be back by the end of the week.
Oh my God.
I know that you all, and parents, if you're listening to this, you will relate to this, but back in the day, you used to be able to drop out of high school at 14. Like there were friends that I knew that dropped out of high school at 14. Magically, they'd go get a job, and suddenly high school is like fascinating. Like work sucks. Like I was working at a pig farm. All I smelled like was pig poop, like all the time. My girlfriend dumped me. I can't even get a date anymore because they just walk in, smell me, and walk out. Like I'm going back to school. Quadratic formula is interesting now. Can't wait to learn that. Okay, what else? Think of another thing that they would want to. Oh no! Here's a good one. Height of bridges. What would they want to use this for height of bridges? Yes.
Like, you see that like ribbon and stuff, like,
Okay. Yeah, we want to probably be able to meet most trucks that are going to go down the road. Now, are we going to be able to meet every truck? No, probably not. Because what if they're hauling like the Empire State Building from Vegas? Yeah, 700 feet. We're not going to build every bridge so that you can drive that underneath there. That's going to be too expensive. But if we could meet like 95% of trucks, then those other 5%, that 1 out of 20, they can figure something else out or go a different route or something. But yes, it would be good to say, okay, if we make bridges between these two heights, 95% of trucks would be able to go underneath them. When we go to bed tonight, think of other applications of this. What else could we use this for? Yes? Washing machine prices, why? Good, washing machine prices, because if you know 95% of people are willing to spend, and I'm just throwing numbers out here, I don't know this data, but between $300 and $850, you would want to have some washing machines between $300 and $850. If all of yours were 900 and above, you'd say, wait a minute, that's outside the 95%. Only 2.5% of people who walk in the door are going to be able to buy a washing machine here. That's probably why we're not selling a lot. What's that? No. Okay, so your homework tonight is a worksheet. There are 2 different scenarios. You need to make a chart like this for it and complete the questions. This is probably the shortest assignment I will give you all year long, though. You have to make the 2 charts, because there's one about ACT scores. Oh, haha, you already did that. And there's one about number. Oh, yes. It turns out the number of hours DCC students spend studying at night is 3.1 with a standard deviation of 0.9. You have to make a chart like that for that. Yeah, I know. You all are like, I wish. 3.1? Yeah. It is. But depending on it, like, think of DP students. They spend like 20 hours studying every night. Well,